Okay, students, for those that are choosing to watch, this is the video to help you do your homework, and this is the assignment right here, page 306, numbers 8 through 23. So if that's not the right assignment you're looking for, you are on the incorrect video. Okay, let's get started. Number 8, the book says to decide whether the figure is a polygon. If so, tell what type. If it's not, tell why. Well, first of all, yes, this is definitely a polygon, most definitely. And what type is it? Well, how many sides do we have? One, two, three, four, five. 5 sides. So a 5-sided polygon is called a pentagon. Moving on to number 9. Well, no, that's not a polygon. Remember, a polygon is made up of segments that intersect at their endpoints. A segment is never curved, okay? It's never curved. So no, that is not a polygon. All right, number 10. Well, yes, that's definitely a polygon, without a doubt. I mean, even though, notice the polygon indents a little bit like that, that's okay. Because look, all of the sides are intersecting at endpoints. None of this is going on. This would not be a polygon if you had a star like that, because there, see how sides are intersecting at places that are not endpoints? And so this is a polygon. And how many sides does it have? Real quick here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you're welcome to call it a tengon. That's definitely a word that mathematicians use, but the technical word is called decagon. You know from the metric system, deca means 10, and decagon. Okay, moving on to the next problem, which is number 11. What is the fewest number of sides a polygon can have? Explain your answer. Well, students, it doesn't take an aeronautical engineer to figure this out. This is number 11. I mean, if you have 2 sides, you can't have a polygon. It's impossible. They're not intersecting. There's an open space here. So the smallest polygon that we can have is 3 sides, and of course we call that a triangle. Okay, there is no such thing as a 2-sided polygon. That is not possible. Alright, so the smallest polygon we have is a 3-sided figure, a triangle. Okay, moving on to number 12. Number 12 says to, let's take a look at it here. Sketch the figure 2 different pentagons. Wow, I am not an artist, that's for sure. Let's see if I can do this. 2 different pentagons. Well, let's try one that's like a regular pentagon where all the sides are congruent. That's pretty rough, but there you go, 5-sided. Now we could do one like this. 1, 2, 3, 4, 5. That's a pentagon. Okay, just one looks weird, but 1, 2, 3, 4, 5. 5 sides. 1, 2, 3, 4, 5. Okay, both of those are pentagons. All right, moving on to number 13. Number 13 says a hexagon with 3 diagonals drawn from a single vertex. Well, a hexagon is a 6-sided figure, so let's get that straight right now. 1, 2, 3, 4, 5, 6. There. And now using a black pen, I'm going to go ahead and draw 3 diagonals from one vertex. So I'm choosing this vertex. And let's do this right if we're going to do it. Alright. And not liking that. Let's make it black. Alright, here we go. There's one diagonal. There's another diagonal. And there's another diagonal. There you go. You did it. You drew a hexagon and put a point right here, and then drew 3 diagonals from that vertex. Pretty simple. Alright, moving on to number 14. Number 14 says draw a quadrilateral with 2 two obtuse angles. All right, well, let's get our two obtuse angles out of the way right now. So there's an obtuse angle, okay, and then there's an obtuse angle. Obtuse just means bigger than 90, and of course a quadrilateral is just a four-sided figure. So now let's go, I mean, there's plenty of ways to do this. I'm just trying to decide how I want to do it. I guess just straight across would be the only option I have right here. So there we go. There is a four-sided figure, 1, 2, 3, 4, four sides. And notice this angle here is bigger than 90, and this angle is bigger than 90. Thus, those two angles are what we call obtuse. All right. All right, number 15. They're asking us to find the measure of angle A. Well, students, this is really almost embarrassing. It's so easy. There's your three angles. Add them up, and you get 289. And remember, all four angles in a quadrilateral, the interior angles have to add up to 360. And so if you subtract, you will get 71 degrees. Okay? Let's go on to the next problem, number 16. And I should have labeled this number 15. All right, number 15. And now let's take a look at number 16. I know these numbers are hard to see, but you've got them right there in your books. You can look at your book. And we're looking at 95, 87, and 63. So 5 carrier 1, 24. So if you add up all three angles, you get 245. Subtract that from 360, and you should get 115 degrees. 115 degrees. Moving on to number 17. I'm not being impatient, but you can always slow the video down, but you can't speed it up, so I'm always going to go fast. Okay, I know it's really hard to see, but this is 100 degrees if you'll look in your book, and this over here is 95 degrees, and then they give you a 90-degree symbol, so you know that's 90. So you have 100 plus 95 plus 90. That would be 5, 8 carrier 1, 285. And then 360 minus 285 should give you 75 degrees. All right? So there's your answer, 75 degrees. Okay, let's take a look at number 18. Number 18, the directions say solve for x. Solve for x. So we have 80 plus 110 degrees plus 65 plus x plus 30. So there. Here's my first angle, second angle, third angle, fourth angle. And when you add up all four of those angles, what should they equal? You guessed it, 360. So you know how to quickly simplify these equations. You should get, wow, I've to do this in my head. This will be interesting. Let's see, 95, 175, 275, 285. So if you add up like terms, you'll get 285 plus x equals 360. Does everybody see where the 285 came from? 80, 110, 65, and 30. Those four numbers. All right? All right, and then of course that's a positive 285, so we're going to subtract 285 from both sides. And if you do that correctly, you should come up with 75 for x. X equals, and my pen is freezing up here, x equals 75. All right, moving on to number 19. Number 19. And I know it's kind of hard to see. This is 60 degrees. This is 150 degrees. And this is 3x down here. And of course, if that's a right angle symbol, then we know we have 90. So we have 60 plus 150 plus 90 plus 3x equals 360. Here's one angle, two, third angle, fourth angle. Add those four angles up and set them equal to 360. So if we add our like terms over here, we're going to be left with 300 plus 3x equals 360. Does everybody see where the 300 came from? 60, 150, and 90. All right. Let's subtract 300 from both sides. So we subtract 300, and you're left with 3x equals 60. All right, divide both sides by 3 and x equals 20. So there we go, x equals 20. These are really, really simple, and I hope you're finding them pretty easy. All right, if you'll look in your book at number 20, this would be 100 degrees right here, and this is going to be 84 degrees, and this is 2x, and this is 2x. So we have our four angles. Do you see the four angles in our quadrilateral? 1, 2, 3, 4. There's our four angles. So we have 100 plus 84 plus 2x plus 2x equals 360. Okay, you should know by now to combine like terms. So 100 plus 84 is 184, and 2x plus 2x is 4x. And that would equal 360. Please don't put 4x squared. That would be wrong. We're not multiplying, we're adding. Okay, let's subtract 184 from both sides. And we're left with 4x equals 176, I believe. And then divide both sides by 4, and you should get 44 for your answer. 44. All right? Okay, let's go on and take a look at number 21. Number 21. I'm going to pause this and get a quick drink of water. Okay, students, back. Number 21 says this. How many sides does the polygon have, and what type is it? Well, I'm going to go to, I guess I'll stay in red. Here's one side, 2, 3, 4, 5, 6, 7, 8. So how many sides does it have? 8. And what do we call that? Well, oops, that should be a C. Octagon. Octagon. All right, moving on. Can't get any simpler than that. All right, number 22. Number 22. Now they tell you this is called Polygon LMNPQRST, and that's how you're supposed to state it. You're supposed to start at a letter and go clockwise. Okay? So they ask you in number 22, state some other names. Well, you could say Polygon, start here, Polygon NPQRSTLMN. Or you could start here, Polygon RSTLMNPQ. Okay? Or you could start here, and you could say Polygon QRSTLMNP. That's a mouthful, but that is the proper way to label polygons. So you could just say Polygon QRSTLMNP. All right, that's it. So that's what they want you to do there. Now, number 23 says, name all of the diagonals that have vertex M as an endpoint. So I'm going to start here, and don't let all these lines that are inside here confuse you. Just go from M, let's do this right, let's go from M to P. Here's M, and we go down to P. So there's one right there, diagonal MP. All right, and then we have diagonal MQ. So there's the next one, MQ. And then we have diagonal MR, MR. And then we have diagonal MS. And then we have diagonal MT. I'm pretty sloppy, but at least I'm getting this, hopefully explaining this well, and hopefully you're getting it. So there's your 5 diagonals. So the question is name them all. There's 5, and there you go. I mean, that's not basically it. That's it. That's how you do it. I mean, look, you can't draw a diagonal from M to N. Okay, that's just a side. And you can't draw a diagonal from M to L. That's just side ML. You can't do that, okay? It has to be coming from a vertex, and drawn to any other vertex except the ones that are right beside it. Okay, I hope this has been a help to you, and keep working hard.